Chemistry is the key to understanding how things work in the world around us. It is the art of balancing equations both in the lab and in life. Without chemistry, there would be no medicine, no technology, no modern agriculture, basically no civilization as we know it. So it is only proper to acknowledge such a study.
Several chemists around the world have worked day and night, which have resulted to the era that we have today. We are Group 3 from STEMB, your hosts for today. To give salutations to the geniuses the world had, let us introduce you to the chemists outside the Philippines.
Let's start with Fritz Haber. Fritz Haber, known for his work in the synthesis of ammonia from nitrogen to hydrogen, which can lead to the development of Haber-Bosch process for ammonia production, crucial for fertilizer and explosive manufacturing.
One of Haber's most famous achievements was the development of Haber-Bosch process, which enabled the large synthesis of ammonia from nitrogen and hydrogen. This process revolutionized agriculture by providing an abundant source of nitrogen for the production of fertilizers. Haber's work in this area was crucial for increasing agriculture productivity and addressing global food shortage.
Fritz Haber, an undisputed genius that saved more lives than potentially anyone else in human history. And he saved those lives completely accidentally while trying to figure out horrible ways to kill people.
It all started in the 20th century where there was a pressing need for an efficient method to produce ammonia. In the 19th, Haber was motivated by the potential agricultural benefits of ammonia production, as it would be used to create synthesis fertilizer and boost crop yields. You may ask, what's ammonia? So what exactly is ammonia?
It is a colorless, highly irritating gas with a sharp, suffocating odor. It's commonly used in agriculture as a fertilizer. To cut it short, the Haber-Bosch process produces ammonia from nitrogen, which covers 78% of our atmosphere, and hydrogen, although 0.14%, it still acts as the most abundant element in the universe.
Developing the process presented numerous experimental challenges. Fortunately, he had a collaboration with an engineer at Badische Aniline Soda Fabrik, or BASF, Karl Bosch.
The process works by bringing the nitrogen and hydrogen gases into close contact with each other and then applying high pressure and high temperature in the presence of an iron catalyst.
Let's give you a quick fun fact about Fritz Haber. Now, did you know that his Nobel Prize in Chemistry in 1819 was somewhat controversial? Well, he was recognized for his synthesis of ammonia, which had immense implications for agriculture and industry. His involvement in the development of chemical weapons during World War I sparks ethical debates about the use of silence for military purposes.
Apart from his work on ammonia synthesis, Haber made significant contributions to electrochemistry, thermodynamics, and the study of reaction kinetics. Robert S. Mulliken, a prominent American physicist and chemist, led a life marked by groundbreaking scientific contributions, academic achievements, and recognition. Mulliken's most significant contribution came in the field of theoretical chemistry. He developed the Mulliken orbital theory, which provided a framework to understand the electronic structure of molecules based on quantum mechanics principles. His work laid the foundation for modern computational chemistry and the field of theoretical chemistry.
Emerging in the 1930s, molecular orbital theory arose in response to the limitations of valence bond theory, which primarily focused on the localized electrons pairs between atoms.
His development of molecular orbital or MO theory stands as a pivotal achievement in theoretical chemistry, fundamentally reshaping our comprehension in chemical bonding and molecular structure. Mulliken, building upon the groundwork laid by quantum mechanics pioneers like Erwin Schrödinger and Max Born, spearheaded the formalization of MO theory.
His innovative insights paved the way for modern theoretical and computational chemistry, profoundly impacting various scientific disciplines and enabling a deeper comprehension of the molecular world.
Fun fact: Molliken collaborates with scientists from diverse fields, including physics, mathematics, and computer science, to advance the fostered theoretical chemistries. His interdisciplinary approach fostered innovation and cross-pollination of ideas.
Up next, we have Ahmed Zewail.
Ahmed Zewail, an Egyptian-American scientist and a renowned chemist and pioneer in the field of petrochemistry. Born on February 26, 1946 in Damascus, Egypt, Zewail's groundbreaking work in phytochemistry began in the late 1980s. He was even awarded the Nobel Prize in Chemistry for his pioneering work and became the first Egyptian and first Arab to receive the prize.
British chemist Rosalind Franklin's work on DNA was far from her only success. For her PhD thesis at Cambridge, she unraveled the structure and porosity of coal, which helped the British develop more mass gas during the World War II. Her later work in RNA and viruses also supported chemist Aaron Claude's work, creating 3D images of viruses, which received the Nobel Prize in Chemistry in 1982. Tragically, she died of cancer before the papers were published and never knew about her competition.
In 1960s, African-American chemist Alice Bull discovered a treatment for leprosy named Bull's method.
Also known as Hansen's disease, is a devastating, highly bacterial infection that has plagued humankind for eons. 23-year-old Bull, the first woman and the first black chemist professor at the University of Hawaii, discovered how to transform comogra oil into fatty acids and ethyl esters to make the medicine injectable. Months after her faculty discovery and appointment, Balls died from complications related to a lab accident. Urey discovered deuterium. He also showed how isotope ratios in rocks reveal past Earth climates, and founded modern planetary science. In 1932, he successfully extracted hydrogen by distilling it with hydrogen. This isotope was called deuterium and is twice as heavy as the usual hydrogen. Urey showed that water containing deuterium has different properties than the regular water. In the late 1950s, Urey became interested in space science. When Apollo brought something from the moon, he analyzed them at the Lunar Receiving Laboratory.
Mario Molina is known for discovering that chlorofluorocarbons could ever destroy the Earth's ozone layer.
He played a pivotal role in the discovery of the ozone discussion, and in 1973, he joined the lab of Professor Sherwood as a postdoctoral fellow. Here, he focused on hot atom chemistry, which involves studying the chemical properties of atoms that have very high translation energy because of radioactive processes. William Francis studied matters at temperatures close to absolute zero and spent almost of all his professional career to the University of California, Berkeley. In 1927, he came up with a new concept of achieving extremely low temperature using the technique he invented, adiabatic demagnetization.
He performed a numerous experiment in 1933. He successfully obtained a temperature of 0.25 Kelvin at negative 272.9 degrees Celsius.
With these experiments, he also confirmed the third law of thermodynamics, which states that the entropy of a system approaches a constant value as the temperature reaches 0 Kelvin. which he was awarded the Nobel Prize in 1949.
Chemistry is beautiful, not because it has some fancy equations or beautiful chemicals, but because of its nature. Chemistry was born out of instability. These reactions that we have in our books, everything that we see around is the result of instability of our universe. If you're the first person to do or see something, you're gonna make a lot of mistakes. There's gonna be a lot of failure because you're pushing for something that nobody knows about. Just imagine how brave these chemists were, no matter the field. Chemistry is the invisible yet undeniable force that binds the universe together. From the tiniest atoms to the grandest celestial body, it shapes our world and fuels our existence. Let's marvel at the beauty of molecules, the elegance of reactions, and the endless possibilities they offer. Embrace the magic of chemistry, for within its realm lies the key to understanding our world and unlocking a future of endless discoveries.